Assalamualaikum. Good morning or good afternoon, everyone. I am Amni Amanina binti Ahmad Jailani, student ID 2023436654. Today, I will be presenting Chapter 2 Literature Review for my project titled Web-Based Food Waste Management and Recipe Recommendation System using Deep Learning. My supervisor is Dr. Muhammad Sufyan bin Sulaiman. This chapter explores several key areas, including application types, reasons for choosing a web platform, existing food waste management systems, recipe recommendation methods, the use of sentence bird, and a comparison with previous studies. To begin, the literature highlights three common application types, which is web application, native mobile application, and hybrid application. Web application run through a browser and require no installation. They are easy to maintain because updates are applied on the server. Native applications such as mobile apps from app stores offer strong performance and access to device features like the camera or GPS. Hybrid application, on the other hand, is the combination of these two. Hybrid applications combine web technologies inside a native shell, offering cross-platform compatibility with slightly reduced performance compared to fully native application. Next, why a web-based platform? A web-based platform is the most suitable choice for this project. Firstly, it offers cross-platform compatibility, allowing users to access the system from desktops, tablets, and mobile phones without needing separate versions. Secondly, updates are centralized, meaning users always get the latest version instantly without downloading updates. Thirdly, a web platform provides high accessibility, allowing users to use the system immediately without any installation. Finally, web development is more cost effective, making it ideal for academic research projects. An expiry management system. Firstly, digital tracking system, for example, barcode-based apps. These allow users to record items and receive expiry reminders. These systems create awareness and reduce forgotten food items. Barcode-based tracking is simple and affordable, but still requires manual scanning and relies on printed expiry labels. More advanced are Internet of Things IoT based predictive systems, which use sensors to track temperature, humidity, and weight. Combined with artificial intelligence AI, they can predict spoilage more accurately. IoT predictive systems are highly accurate, but due to cost and complexity, they are unrealistic for everyday use. This project focuses on a middle ground, which is a simple but effective web-based system where users only enter items they are most likely to forget, and the system prioritizes near expiry ingredients. This makes the system both accessible and user-friendly. Next is recipe recommendation methods. Recipe recommendation techniques have evolved significantly. The traditional method used TF-IDF with cosine similarity which compares recipes based on ingredient keywords. This method is fast but cannot understand deeper meanings. More modern systems use convolutional neural networks CNNs, where users can take a photo of ingredients and the system detects them automatically. Hybrid AI models combine multiple algorithms to consider factors like user preferences and nutrition. Finally, transformer-based models, such as BERT or SBERT represent the latest advancement, offering deeper contextual understanding. I'll be talking about the limitations of traditional methods. Although earlier methods work, they have clear limitations. Keyword based systems cannot recognize relationships like ripe bananas and banana fruit. They are not flexible and do not handle ingredient substitutions well. They also struggle with context, making recommendations less relevant. And most importantly, they do not incorporate expiry information, meaning they cannot prioritize ingredients that are close to spoiling. Because of these limitations, more advanced models are needed. Next, I will be talking sentence BERT as BERT, which will be used in my project. SBERT is a variation of BERT that creates semantic embeddings for sentences, meaning it understands the meaning behind the text instead of matching only keywords. It allows for similarity comparison because it encodes full sentences into mathematical vectors. It also handles vocabulary differences. Understanding of ripe bananas is related to banana bread even if the exact words differ. This makes SBET ideal for ingredient recipe matching and helps generate more accurate and practical recipe recommendations. Next, listen with previous works or studies. Firstly, we have Tinirani Beni. Tinirani Beni used TF-IDF, but it lacks semantic capability needed for more accurate recommendations. Next, use update, which focus on behavioral change, shows that planning meals with existing food reduce waste, but it lacks automation. Next, recipe IS use CNN image recognition for ingredient detection, but has no expiry tracking. Takahashi and Sasaki's system, lastly, includes expiry tracking, but use only basic recipe search technique. So, lastly, is the chapter. To conclude, Chapter 2 reviews the foundation that support this project. A web-based platform ensures accessibility and low maintenance. Food waste management system highlight the importance of expiry tracking and reminders. Recipe recommendation techniques have evolved from simple keyword matching to advanced deep learning. SBERT provides the semantic understanding needed for more effective ingredient-based recipe suggestion. And finally, existing studies lack a combined solution that focus on both expiry management and intelligent recipe matching. This literature review justifies the direction taken in developing the system in this project. Thank you, and I hope everyone has a good day.